Okay, welcome back to another Physical Sciences 3 lecture. In this example, we have two railway carriages approaching each other. Carriage P has mass of 50 tonnes, is travelling at 3.0 metres per second north, and Q, so carriage Q, has a mass of 75 tonnes, is travelling at 4 metres per second south. Okay, so we're going to say that north is positive. Say north is positive in this case. And let's just draw what happens. If the carriages coalesce, just remember that means stick together. So if they coalesce, they stick together. Okay, so we have P travelling north, and then Q travelling south. And then afterwards, so this is before, and then afterwards, they stick together. P and Q stick together and they go off in some direction, and I'm going to predict it's going to end up being in a southwards direction. Okay, so let's have a look. So momentum before and after. We write it a bit differently this time. So in this case, we have M1 U1, so for P, plus M2, this is after, remember, M2 U2, so that's our initial velocities times by the masses. And this time, instead of M1 V1 and M2 V2, I'm going to say this is going to be equal to M3, and I'm just going to say one velocity, because we can treat this as one object, so a third mass, in a sense. Okay, so we had M1 and U1 were both, it was 50 times 1,000, so that's our first mass, so 50 tonnes, we can rewrite that as 50 times 10 to the 3. And times we're going, that's going north, so north we've said is positive, so that's 3 plus 75 times 10 to the 3, and U2 is 4 metres per second, and it's going to be negative 4.0, 3.0. So it's negative in this case, because we said that north was positive before. So for our third mass, it's going to be equal to 50 plus 75, and that's all times by times 10 to the 3. Okay, so it's going to be our 125 tonnes of train, and we don't know what our final velocity is, so their resultant velocity. So let's work all of these out then. So we're going to put these into our calculator. So we're going to have 50 times by 3, and I'm going to say subtract 4 times 75. Okay, so it's negative 150. So minus 150 times by 10 to the 3 for our tonnes, and then we're going to have that's equal to 125 times 10 to the 3 V. Okay, so V is going to be equal to, we're going to divide both sides by 125 times 10 to the 3, so we'll have negative 150 times by 10 to the 3 over, scroll down a bit, oops, we want that up here, like that. Okay, divided by 125 times 10 to the 3. Okay, so these will cancel out like that, so it'll end up being negative 150 divided by 125. So it's equal to negative 1.2. Negative 1.2 metres per second. And like we said, or like I predicted, it's opposite of north, so it's equal to 1.2 metres per second south. Okay, if you're asking how did I predict it, I didn't go through and do the problem beforehand. What I did was I just looked at the numbers here. We had 50 times 3 was smaller than 75 times 4, so that's why I predicted it was going to be in the southward direction. Okay, Very good. We'll finish off our conservation of momentum problems in the next lecture.